Hello everyone, my name is Dan the Tutor, and today we're going to be talking about AP Calculus AB, specifically limits. Limits is the first big topic in calculus, and for that reason, we're going to be spending a decent amount of time on it. So today, we're talking about limits. And the cool thing about limits, well actually there's not a lot of cool things about limits, but one of the cool things about limits is that we're going to introduce a new kind of definition for, a very basic principle in math. And here's what it is. If I have a graph, if I have some graph that looks like this, and I have x and f of x, and I just have, some kind of linear line here, like this, and I wanted to know the value at x equals 3, and I can even draw the dotted line here, and this can be y equals 2, or f of x equals 2, and we could say the point right here is 3 comma 2, right? Like the value f of 2, or f of 3. Like if we were to plug in 3 into this function, then we would get an output of 2. So thinking about input, output, f of 3 is equal to 2. Now, here's where limits get interesting. The notation of limits is we're going to say lim as x or some variable approaches some number, in this case 3, f of x. And this is a lot of fancy stuff going on, but it says the limit as x approaches 3 of f of x. And it's kind of hard to explain what it means, so I'm just going to tell you what it is. It's 2. It's actually, in this case, the exact same as the actual value of the function at f of 3. And the reason for that is because, we see the dot here, it's at 3 comma 2. And we also see that the graph from both sides, from both the left side and the right side, it's approaching the same number. It's approaching value of 2. And so now, what if I said there was a hole in the graph at 3, where there's no y value? And we can give it a y value, if we have an open hole in the graph, we can put the actual y value at, 4 here. And now this changes a little bit, so no longer does f of 3 equal 2, now we can say f of 3 is equal to 4. In other words, the actual value, like if you were to plug in 3 into this function here, you get an output of 4. And the reason that is at this exact point 3 is because there is a dotted line, a dot right there, a closed circle, if you will. And so that means the actual value at 3 is 4. And the funny thing is that every other value on this line, like if we think about, this line here going up and down, it looks like it's approaching the value 2, right? Like it's approaching 2 at every possible point except for the actual point x equals 3, where there's the open circle. And so what that means then is the limit now at x approaches 3 f of x is actually still 2. In other words, limits do not care what the actual value is. Limits do not care that there's a closed circle here and an open circle here. Limits just care what value it's approaching from both sides. And if it's approaching 2 from the left and it's approaching 2 from the right, then the limit is 2. And you may be wondering, well, why is that? Why do we even have this limit notation? Limits, I think, are important for 2 reasons. 1, they account for holes in the graph, like we can see here. And 2, they account for vertical asymptotes, as you'll see later. And of course, there's a lot of applications with limits, especially once you start getting into limit definition of derivative. But for right now, the biggest thing you want to think about is the reason we have limits is specifically because of holes in the graph and because of vertical asymptotes. Now let's look at another example. Let's say we have at the point f of x is equal to 2, we have this line here, and it's got a closed circle at x equals -1. It's going to have an open circle down here at -2, and that's going to go all the way to that point right there, which we can say is +1. We'll have an open circle here, and then another open circle here at f of x equals 2, and then a closed circle at x equals 2 now, and then we can just say that goes down linearly. So here's our graph. And I want to know, my question is, first of all, what is the actual value at each of these 3 points? So for instance, the actual value, like if I were to look at what the actual value of f of x at x equals -1, the actual value is going to be 2. Why? Because we have that closed circle right there. And so for that reason, the actual value is 2. Open circle means it's not that value at that point. And then if we look at f of 1, that point actually does not exist. There's no value there. I can write DNE, which stands for does not exist. That's what DNE is going to mean. And technically, you're not supposed to say equals DNE. you would just write f of 1 dne does not exist. And then lastly, we have f of 2, and the actual value of f of 2, forgot to connect the line here. The actual value of f of 2 is also 2. So we have our actual values here. And now I kind of want to think about, well, what's the limit at each of those points? And remember, the limit is saying what value are we approaching from both sides. And so we can start with the limit as x approaches -1 f of x. And remember, the limit says what value are we approaching from both sides. So my question for you is, what value are we approaching from the left? Well, I would say we are approaching 2 from the left, but we are approaching -2 from the right, right? Like we're approaching +2 from the left, -2 from the right. What's the limit in that case? They're approaching 2 different numbers. The limit, I'm going to tell you, does not exist, DNE. And the reason for that is because it's approaching 2 different numbers from both sides. Okay? It's approaching 2 different numbers from both sides. The limit does not exist. Now we can do the exact same thing at the point x equals 1. And the way we notate that, limit as x approaches +1 f of x. Remember, there is no actual y value here, but it doesn't matter because the limit just says what value are we approaching. And so we're approaching from the left. From the left, we're approaching -2. And from the right, we are approaching +2. And for that reason, once again, they're approaching 2 different numbers. So the limit, again, is not going to exist. I'm going to write does not exist there. And lastly, we can also say what's the limit as x approaches +2. And in this case, remember the actual value of f of 2 is +2. But remember, that doesn't matter. We need to look at what value it's approaching from both sides. So from the left, we see it's approaching +2. And from the right, we also see that it's approaching +2. So in this case, they're approaching the same number. And the fact that it's a closed circle or an open circle does not matter. That could be an open circle there. It does not matter because we just care about what value it's approaching. And it's approaching the same number from both sides. So we can say the limit f of x is equal to +2. Okay, now let's look at an even tougher example. I have here x and f of x. And let's say we have this function here. Okay? And now we want to know what the limit is at each of these 3 points. At this point, I'm not even going to ask about the actual values because the actual values at all points A, B, and C, there actually is no value because they're all open circles or vertical asymptotes. So there's no value at f of A, f of B, f of C. But the limit may or may not exist, and we're going to find that out together. So first of all, the limit as x approaches A, f of x is equal to what? Well, we think about what's it approaching from the left. It's approaching 0 from the left. From the right side, it's also approaching 0. And so if it's approaching the same number from both sides, the limit is just going to be 0. For point B, we have from the left, it's approaching +3. And from the right, it's also approaching +3. So the limit here also exists. The limit as x approaches B, f of x, that's going to equal 3. Again, even though there's an open circle there, we just care about what it's approaching from both sides. And then for the vertical asymptote with limit as x approaches C, f of x, let's think about this one. So from the left, it's approaching, if it's a vertical asymptote, by the way, then we know that's approaching -infinity if it's going down. Like it's heading towards -infinity, it's going to keep going on forever. From the right side, it's approaching +infinity, right? And so since from the left it's approaching -infinity, from the right it's approaching +infinity, we're going to say does not exist here because the limit is approaching 2 different values from both sides. But then you can also ask yourself the question, hey, what if I was approaching -infinity from both sides? Like instead of this +infinity here, what if we had something that looked like this and it was actually heading towards -infinity from the right? And so now you have an interesting case where it's approaching -infinity from both sides, right? And so you would be tempted to say that the limit as x approaches C, f of x would equal -infinity. And I'm not going to say -infinity is wrong just because it looks like it's approaching -infinity from both sides. But one thing to know about limits is that if your limit is equal to infinity or -infinity, even if it's the same from both sides, If it's ever equal to positive or negative infinity, you have to write does not exist. You cannot say negative infinity alone. That would be considered wrong. You need to include does not exist because it's approaching positive infinity or negative infinity. If you're wondering why that rule is, I do not make the rules. I like the rule where it's negative infinity because that makes sense to me, but I did not invent math. So for that reason, we have to write does not exist. And that's pretty much a basic introduction as to what limits are, how they're different from the actual value like f of x, and how you can compute them using graphs. I'm Dan the Tutor, and thanks for watching.